of this lecture, I will say some basic question based on inner product, positive definite, negative definite and indefinite matrix, which had come in different comparative exam. First question comes CSIR NET 2021 exam. The question is, which of the following are inner product on R2? Inner product x1 y1 here x1 x2 y1 y2 equal to x1 y1 plus 2x1 y2 plus 2x2 y1 plus x2 y2. Option 2, inner product x1 x2 y1 y2 equal to x1 y1 plus x1 y2 plus x2 y1 plus 2x2 y2. Option 3, inner product x1 x2 y1 y2 equal to x1 y1 plus x1 y2 plus x2 y1 plus x2 y2. Option 4, inner product x1 x2 y1 y2 equal to x1 y1 minus half x1 y2 minus half x2 y1 plus x2 y2. Here we have to find, is this inner product? Here I will use, all of us know, positive definite symmetric bilinear form is an inner product, and if A be real positive definite matrix, then the function inner product UV equal to U transpose AV is an inner product on Rn. Here I will use this method. That means from this expression, at first create one symmetric matrix, then I will check is this matrix is positive definite or not. If positive definite, then obviously this is an inner product on here Rn mean R2. From this expression, I will create one symmetric matrix. One here x1 y1, the coefficient of x1 y1 is 1 and coefficient of x2 y2 is 1, and x1 y2 coefficient of x1 y2 and x2 y1 is 2, so here would be 2. This is the matrix A, and notice this matrix is symmetric matrix obviously, and check the determinant. Determinant of A is 1 minus 4, which is minus 3, which is less than 0. We all of us know if determinant is less than 0, then the matrix is negative definite. So this matrix is not positive definite. So option 1 is not inner product. Now check option 2. From this expression we can generate one matrix A such that 1, 2, here also 1, 1. Then determinant of this matrix would be 2 minus 1, which is 1, which is obviously strictly greater than 0. So this matrix is positive definite, and since positive definite, so obviously quadratic form is an inner product. So this option is true. Now let's see the third option. From this quadratic form we can generate A equal to here 1, 1, here 1, 1. So determinant of this matrix would be 1 minus 1 equal to 0. So this is not positive definite. So option 3 also wrong option. Now let's see the option 4. Matrix would be such type 1, 1, here minus half, minus half. So determinant of the matrix would be 1 plus 1 over 4, which is actually 3 over 4. Here minus 1 over 4, which is 3 over 4, which is strictly greater than 0. So this matrix is positive definite, and since positive definite, so obviously this is example of inner product. So option 4, right option. I hope my all viewers have understood this question. This question is basic question which had come in CSIR NET 2021 June exam. This is very basic knowledge, and my all viewers have understood this question easily. Our next example, which had come CSIR Net 2022 exam. The example is, consider AB belongs to R and consider P of xy equal to a square x1 y1 plus AB x2 y1 plus AB x1 y2 plus b square x2 y1, where x equal to x1 x2 and y equal to y1 y2 belongs to R. Here the question is, for what value of a and b does the function, here the function as denoted as p from R2 cross R2 to R, defined an inner product? Option 1, for a greater than 0 and b strictly greater than 0. Option 2, ab strictly greater than 0. Option 3, a equal to 0 and b equal to 0. Option 4, for no values of a and b. From this quadratic form, we can generate one matrix A equal to a square b square AB. Here AB and here AB. Then obviously determinant of this matrix would be a square b square minus a square b square, which is obviously equal to 0. This question and previous question are actually similar. Here the question is, for which value of a and b this quadratic form be an inner product. Notice, from this quadratic form we can generate one matrix whose diagonal would be a square b square and off diagonal would be ab. Then determinant of this matrix would be obviously a square b square minus a square b square, which is equal to 0. And since determinant of this matrix is equal to 0, that means this matrix is not positive definite. Have you understood this question? So, since this matrix is not positive definite matrix, so this matrix is not inner product. Have you understood this question? So, here the notice the option. Here inner product, option 1 indicate inner product for a greater than 0 and b strictly greater than 0. Option 2 indicate ab strictly greater than 0. Option 3 indicate a equal to 0 and b equal to 0. And option 4 indicate for no values of a and b. Option 4 is a right option. This is not inner product. So, for no values of ab, this is not be an inner product. Have you understood this question? I hope my all viewers have understood this question easily. Okay? Oh well. Now I will see another question which had come CSIR Net June 2017 exam. The question is, consider this matrix. Notice this matrix is symmetric form. And consider the quadratic, we all of us know the quadratic form is written as such type x transpose ax, where for all x belongs to R3. Then option 1, A has exactly 2 positive eigenvalues. Option 2, all eigenvalues of the matrix A are positive. Option 3, qx greater than equal to 0, and this is true for all x belongs to R3. And option 4, qx strictly less than 0, this is true for some x belongs to R3. Notice I will here, this is true for some x belongs to R3. Okay. Here this is the quadratic form. At first notice, in the first option indicate A has exactly 2 positive eigenvalue. Notice interesting thing here. Here each row sum of this matrix is 6. So obviously we can tell 6 is an eigenvalue of this matrix. Okay. Oh well. Also notice trace of this matrix also is 6. That means, since trace means sum of the eigenvalue, since 6, I have got 6 is an eigenvalue. That means other eigenvalue would be such type 6 plus a minus a, and this sum would be 6. So, eigenvalue would be such type. If this is a, then another eigenvalue would be minus a. Then this would be 6. That means option A is a right option. A has exactly 2 positive eigenvalues. And option 2 is a obviously wrong option. All eigenvalues of A are positive. This is wrong option. Option 3 indicate Qx greater than equal to 0. This is true for all x belongs to R3. This is also wrong option because this is the definition of positive semi-definite. Since I have got one matrix is negative, so obviously third option would be wrong. And option 4 indicate Qx less than 0. This is true for some x belongs to R3. This is obviously right option. Because from this expression we can tell there exists one eigenvalue. This is which is negative. So, for this negative eigenvalue, we can tell Qx strictly less than 0. And this is true for some x belongs to R3. This is fourth option is true because here it has indicated for some x belongs to R3. That means option 1 and option 4 is a right option. I hope my all viewers have understood this question. Okay? OL. Today I will stop here. In my next video, I will discuss this type of question again. Okay? See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos.